Hey everybody, this is Professor Ross, and in this video we'll be talking about comparing two means, doing statistical inference with a simulation-based approach. Let's take a look at some notes here. So we'll be comparing two means, which indicates we've got a quantitative variable, and our quantitative variable is our response variable here. We've got two means because we've got a categorical variable with two groups, a binary categorical variable. That is our explanatory variable. So we've got an explanatory variable splitting our people up into two groups, and then we're looking at the quantitative results in those two groups and comparing their mean results. We want to be able to make a conclusion about something broader than just our sample. So we want to do inference, and we'll do inference with a simulation-based approach. The good news is the simulation-based approach is going to be very similar in feel to what we've done before with the 3 S's and using an applet to run the simulation. One of our key learning objectives here is to continue to use the logic of statistical decision making. And that logic follows the same flow as it has going through simulation and the 3S approach to make a decision based on a p-value or a standardized statistic. So let's take a look at an example. Here's might be a question of interest. Is the typical college structure biased against introverts? Oftentimes students are required to meet and work together quite a bit, give presentations. Those might be the kinds of things that introverts might be less interested in. Teachers often seem to respond well to those who are speaking up in class and maybe more extroverted in general. So should we see introverts maybe struggling some more in college? How could we examine this question? Well, we could test two hypotheses. A null hypothesis might be something like the average GPA for introverts is equal to the average GPA for extroverts. And that would mean there's no association between whether you're introverted or extroverted and what your GPA turns out to be. So our null hypothesis, whenever we've got two variables involved, our null hypothesis is going to be there's no association between those variables. Here, GPAs turn out the same whether you're introverted or extroverted. How do we symbolize that? We could write this null hypothesis as mu for the introverts equals mu for the extroverts. Mu here is the mean, and that would be mean GPA for the whole population for all introverted students, being the same as the mean GPA for all extroverted students. Now, this is a nice way to look at it and think about it, but I actually prefer this format here, which is mathematically equivalent. If you think a little bit about algebra, we can just subtract mu extroverts from both sides. Another way to look at this is to think about if I were to subtract these two, the mean GPA of the introverts and the mean GPA of the extroverts, I would end up getting 0. The only way that could happen is if these two are the same value. So these mean the same thing. I prefer this one because we're going to find out that our statistic, the structure of how we think about our statistic and how we calculate it mirrors this mu introverts minus mu extroverts, but in our sample. What's the alternate hypothesis? That there is some kind of association here, and we're suggesting that introverts maybe are going to have a harder time. So here, the average GPA for introverts is less than the average GPA for extroverts, and here we see mu introvert less than mu extrovert. Or once again, the equivalent, if I subtract mu introvert minus mu extrovert, smaller minus bigger, I'd end up with a negative number, something less than, excuse me, less than 0. So how can we test these hypotheses? Well, first, let's think about some data we could use to check them out and explore our data a little bit. We're going to explore it with the multiple means applet, and I've got some data from several introductory statistics classes that I've gathered over the years. So we're going to create some dot plots and box plots and examine group means and standard deviations. Let's jump over to the applet and see how that turns out. And here, when we're looking at our selection of applets, one thing to take note is that we've got more and more to choose from because of all the different scenarios we've run into. Whenever you have a categorical explanatory variable and a quantitative response variable, you'll be thinking about using the multiple means applet. And whoops, I actually have, I had that pulled up already. I have data already put in here. Let me just close this for a second. This is the data that I got from my statistics students over the past few years. It comes with some data in there. You can clear it out and paste your own data in. And if you've got your own data, for example, for your project, and you've got your data in a spreadsheet, you should just be able to highlight it all, copy it, and paste it in here. So once I hit use data, I can see my graphs, and just taking a look at these distributions, here are my extroverts and their GPAs. Here are my introverts and their GPAs. Each of them has a couple of lower outliers, and then the bulk of the data is really up here in the kind of around 3 GPA, spread around three GPA for both. It's not really looking very different as far as the centers of these go. And if I choose the box plots, we can see that the median for each of them is really not too far off. In fact, it's a little bit higher for my introverts than it is for my extroverts. I can also look at the means. If I look down at the summary statistics, for the extroverts, the mean GPA is 3.13, and for introverts, 3.20. I'm seeing the opposite of what I thought might happen. That introverts GPA is a little higher than mean GPA, but it's really not very different at all. They're very, very close to each other, the means. So the spreads really aren't that different, maybe a little more spread because of these lower outliers for my introverts. What I'm seeing here as I explore the data is I shouldn't expect to see a difference in the mean GPAs out in the population because the sample GPAs are so close to each other. So how can we actually find out if we've got a difference in the population? We can do our 3S strategy and use a simulation-based approach to do statistical inference. So our 3 S's, our first is statistic. What is our statistic? Here it is, the mean GPA of introverts minus the mean GPA of extroverts. And as I suggested, that mirrors what we had in the hypothesis, except this is for the sample instead of for the whole population. And how do I calculate this? Well, the applet does that for me. It calculates the mean of each of those, and it actually shows me the difference. I'm going to hop back over and show you where that difference is. If you look down here, observed difference 0.069, that is the difference between these two means. And here, since it's positive, you can see it's doing introvert minus extrovert. So, so that's our statistic, the observed difference. You'll notice there are a number of different statistics we could look at, but for our purposes now, we're going to stick with the difference in means. So there's our first S, our statistic, and as we mentioned, that's pretty small. There was not a very big difference in that mean GPAs. Next, we simulate. So how do we simulate this scenario? Well, we want to simulate our null hypothesis, our null assumption, that it doesn't matter as far as GPA goes, whether you're introvert or extrovert. So how can we simulate that? Well, essentially what we say is, we think you'd have the GPA that you'd have, no matter whether you're introvert or extrovert. So what we could do if we wanted to do this physically, we could fill out a slip of paper for each student and write their GPA on it, and then just randomly shuffle them up and deal them out into an introvert pile and an extrovert pile, matching the number of introverts and extroverts we have in our sample. That's matching this idea that it doesn't matter if you're introvert or extrovert, your GPA is going to be what it is. So we do that, then we calculate the mean GPA for each randomly shuffled pile and find the difference in the means, and we see what that difference looks like. If our difference looks something like the differences we tend to find with this, then we feel like, okay, what we saw goes along with that null assumption. If our difference looks very different from the kinds of differences we'd see with this process, then we feel like, oh, that null assumption doesn't seem to match what we found. We may have found a statistically significant difference. So that's the idea with simulation. And then our strength of evidence is what we were talking about. How does our sample result compare to what would have happened under the null hypothesis? Let's try this out with the simulation applet, finish these last two steps of our simulation-based approach. So we're gonna find what we need to by clicking on Show Shuffle Options here. And what this is gonna do, let's just try one out. It's gonna shuffle once. It's using the hypothesized difference of 0, so that's what we said we want, and almost always we're gonna leave that as 0. And I'm gonna go ahead and shuffle it up. You can see what's happened is instead of the first introvert having a GPA of 1.08, it's been shuffled to a 2.95. And then instead of a 2.5, a 2. So all the GPAs got shuffled up. You can see that we kept the number of extroverts the same, 48, and introverts the same, but their means turned out to be different, 3.11, 3.22, and so we got a slightly different shuffle difference there, and we got a box here representing that shuffle difference. If I shuffle them again, I get some random mix up here, and this time I got a little bit higher difference. And if I try these out a few times, we'll start to see a few negative differences show up as well. What's a negative difference mean? That simply means that the mean for extroverts turned out to be higher than the mean for introverts. When I subtract 3.10 minus 3.25, I get a negative 0.16. There must be a little bit of rounding in there. So we see some positives, some negatives. That's not too surprising. They're all centered around this true difference of 0 that we're hypothesizing. The key thing I want to do is look for something to happen in the very long run. So I'm going to go ahead and do 1,000 shuffles. You might have seen me do 10,000 before, but with a large data set like 106 numbers in there, it's going to kind of bog it down at 10,000. So I'm just going to stick with 1,000. And you can see it's taking a little bit of time even with just 1,000. And if you want to, you can hit shuffle a couple of times, get yourself a couple thousand. But for our purposes right now, 1,007 is plenty. What do we want to find out? Well, we want to find out what the null hypothesis would suggest should happen. If there's really no difference being extroverted or introverted, we'll see no difference in GPAs a lot of the time. Seeing something even as big as a 0.2 difference or a negative 0.2 difference, or even maybe a little higher than that, it's not going to be all that crazy. When we start getting out like a 0.4 difference in our mean GPAs, that's where we start seeing some strange kind of results. What was our result? Our observed difference was 0.069. So let's go ahead and count how often 0.069 showed up. And you can see, oh, and I've used the less than. Why? Because I believed that introverts GPA would be less than extroverts GPA. So my alternate hypothesis said I should look at less than. It's one of the rare instances where I actually guessed wrong. Introverts were higher than extroverts. And now I'm looking at more than half the null distribution shaded in here. This is a really high p-value. Here's my p-value in red, always in red on these applets, 0.718. There's about a 72% chance of seeing a result like our difference or lower if the null hypothesis was really true. Very likely to see a small difference like this if there truly is no difference between the two groups. So, whoops, I didn't mean to do that. I just want to go back to this. So we have a high p-value. We have little to no evidence against that null hypothesis. And the null hypothesis claim that there's the average GPA for each group is the same is what we should continue to assume. Let's talk a little bit about a 95% confidence interval. The applet will also calculate that for us. And I want to show you this because it's a little bit of a subtle thing. If we look down in the very lower left-hand corner, we can see a checkbox for the 95% confidence interval. So we can check that and get that 95% confidence interval. You can also use the 2SD method. So we could take the SD from the null distribution here, double that, and add and subtract it to our difference. That's essentially how they got this with a little bit slightly more exact multiplier. So our 95% confidence interval is negative 18%, or excuse me, no, we're talking about means, negative 0.18 up to positive 0.32. What is that all about? Well, we feel 95% confident that the true difference, not in our sample, but the true difference out amongst the population in GPAs of introverts and extroverts would fall somewhere in this interval. So it's always the parameter that falls in here. And the parameter is the difference in the mean GPAs of introverts and extroverts amongst all students. What is that telling us? Well, if it were negative, who would end up with the higher GPA? So this is kind of how I walk through this in my mind. I think about each end and what that would imply. A negative result, if I'm doing introvert minus extrovert, that means that the extroverts had the higher average GPA because small minus big would give me a negative number. So I feel confident it could end up with introverts with a higher GPA. But look, the other end is positive. That means, the negative means extroverts would have a higher GPA. The positive means introverts would have a higher GPA by a little bit. In other words, I can't really tell who's going to have the higher GPA. And that goes right along with our conclusion to the test. We shouldn't believe that there's any difference between the two groups. We can't claim one is clearly going to have the higher GPA over the other. So that's how our 95% confidence interval works. And it coincides right with what we found from the p-value. Let's talk about a few other things with the conclusion. We can conclude that there's no difference in the average GPA. And is Maryville College biased against introverts? We don't have any evidence of that from our data. Are we justified in generalizing this to all of Maryville College? Well, I only talked to intro stats students, so that might not be justified. Maybe we could say it doesn't seem to be any bias as long as these are students from my intro stats classes. Could we be justified in making a cause and effect conclusion? Two reasons why not. We don't have any effect. We didn't see any difference in GPAs. But even if we did, we still couldn't claim cause and effect because we did not do an experiment. We only did an observational study. In other words, we did not assign students to our two categories, introvert and extrovert. We didn't tell students, you must be an introvert and you must be an extrovert. If we randomly assign them to that, then we'd have an experiment, but of course, you can't really do that. We are at risk of a type 2 error because we retained the null hypothesis. So we might have missed an opportunity here. I perhaps could have had a more powerful test with a larger sample. Something like that could have perhaps led us to find at least a small difference in mean GPAs, but we have a type 2 risk here. We don't know what chance it is without doing an analysis of the power of this test. What could have we done better? Instead of just sampling my convenient sample of intro stats students, we could have talked to a random sample of all Maryville College students, or maybe even look beyond just Maryville College and think about other schools as well. So that's how we compare two means with the simulation-based approach.